Okay, so in your book, where I want you right now is actually on page 376, because on page 376 is where section 8.5 starts, and it has the different theorems. So we can make sure we've got the right words in there, and then we'll go from there, okay? So on section 8.5 on the notes in the orange folder, the first theorem it has is there at the top of page 376 in green. It says the measure of an angle formed by a tangent and a secant that intersect at the point of tangency is 1/2 the measure of the intercepted arc. So when you have a secant and a tangent, it's the same as if we had two chords or two secants yesterday when it was half of the intercepted arc, okay? So that part's the same. We got everybody now, good. Okay, we're going over your section 8.5 notes to make sure you have those ready, and we're looking at page 376. All right, so we have that. That was the first theorem. The next theorem is on the top of page 377. It says the measure of an angle formed by two secants that intersect in the interior of a circle, interior means inside, is 1/2 the sum of the measures of the intercepted arcs. So sum means you do what with them? Add them together, so it's half of the sum of the intersected arcs. And then the theorem down at the bottom of that page, well, it's about halfway down, says the measure of an angle formed by two secants that intersect in the exterior of a circle is 1/2 the difference of the measure of intercepted arcs. So if it's secants that intersect inside the circle, you add the two arcs together and divide by 2. If it's secants that intersect outside the circle, you subtract the two arcs that they intercept and divide by 2. So if it's inside, you add. If it's outside, you subtract. Okay, then the next theorem on page 378. Okay, so it's on the back of your notes page. It's the very last notes page that you have for chapter 8. Okay, we have theorems there in the box. Said the measure of an angle formed by a secant and a tangent that intersect in the exterior of a circle is 1/2 the difference of the measure of the intercepted arcs. And then the measure of an angle formed by the intersection of two tangents is 1/2 the difference of the measures of the intercepted arcs. So basically the main thing you need to remember, if it's inside the circle, you're going to end up adding and dividing by 2. If it's outside the circle, you're going to end up subtracting the arcs that it cuts off and dividing by 2. So inside we add, outside we subtract. Everybody get those filled in? You have those? Adria, I told you yesterday, you don't get to hide.
I'm not hiding, miss.
We are. All right. So
I'm here.
now we're ready to start on page 379. Okay, on page 379, we're going to be trying to work on 1 through 30 today. We'll see how far we get. Hopefully we get through them. If not, that's okay. We'll finish them up tomorrow. Okay. Now, what we're doing in these first questions is going over those theorems that we just made sure we filled in correctly on our notes paper. Okay. So on number 1, it says, complete the following theorem combining the 3 cases in theorem 853A, 853B, and 853C if the vertex of an angle intersecting arcs of a circle is in the circle's exterior, the angle's measure is what? If it's on the outside of the circle, what did we say it was? Do we add them or subtract them? If it's on the outside, we add. So it's equal to half the intercepted arcs. Okay? Half of the difference of the intercepted arcs. Okay? I'll mute you and then you can unmute as you can. You can answer. Okay? So basically, remember I said if they intercept on the inside, it's half the sum. If they intercept on the outside, it's half the difference of the intercepted arcs. Okay. Number 2, it wants us to actually sketch the 3 cases for exercise 1. So it wants you to actually sketch pictures of these circles that it's talking about. Now the first one dealt with the secants. Remember a secant? You have your circle, and secants are lines that go across the circle, and they intersect the circle at 2 points. So I have a secant that goes across this way, and I can have another secant that goes up that way. But they intersect on the outside of the circle, so that would be a case of the first theorem. Okay. The second one talked about when you had a secant and a tangent. Now, the secant goes across the circle, tangent just touches the circle. So for your second one, you have your secant going across the circle, and then you have your tangent that touches the circle. And they're intersecting on the outside. I didn't draw that very good. Here, let me draw it. I'll draw it up here. If I draw it up here, it'd be easier for y'all to see where they touch. There you go. Okay. They intersect on the outside, but you got a secant and you got a tangent. And then the last case that we had were 2 tangents. So 2 lines that just touch the circle. So you draw a circle, and I know your circles probably aren't gonna look great. I can't draw a circle either. All of mine are like squished. You have a tangent, touches on the outside here. Tangent that touched on the outside down there. And they intersect up there. So your pictures don't have to be great, but just understanding that they all cross in the exterior outside of the circle. Okay? So that was for number 2. You had the 3 different pictures. Number 3 says complete the statement. If the vertex of an angle intercepting arcs of a circle is on the circle, the angle's measure is 1/2 the measure of the intercepted arc. Okay, and that's what we did yesterday too, but those inscribed angles. When the vertex is on the circle, the measure of the angle is 1/2 of the arc that it intercepts, the section of the circle that it cuts off. Okay. Now, number 4 is wanting us to draw pictures again. They're insistent on making us try to draw in this section. It says sketch the 2 cases for exercise 3. Label each case with the corresponding theorem number. So I already wrote the theorem numbers here. The first theorem was 851 and the second theorem was 841. Okay, so 851 is when you have a secant, and then you have a tangent, and they intersect at that point of tangency. So this would be the arc that they intercept. Okay, you have the secant, and then you have the tangent. Okay, everybody got that? And then the second one is the one that we just talked about yesterday. Notice it says 8.4 instead of 8.5. That tells you it was in section 8.4 that we did yesterday. You have your secant. Okay. So, and then you have the two lines that intersect inside the circle, or actually on the circle. So you're gonna have a picture, you got a line like this, and then you're gonna have another line like that, but they touch right on the circle. So this is an inscribed angle, and this would be the arc that we're talking about that it intercepts. On this one, this is the arc that it intercepted. Okay. So everybody got those? All right. And then the next part, we have number 5 says, complete the statement if the vertex of an angle intercepting arcs of a circle is in the circle's interior. So if it's on the inside, remember I said the angles are half the, not difference, but sum. So for number 5, it's half the sum of the intercepted arcs. Okay, it's half the sum of the intercepted arcs. Okay. Okay. And then again, it wants a picture. So that's when you have the circle and you have the two secants drawn, but they intercept inside the circle. So you have the two arcs that it's intercepted here that you would add together and divide by 2 to find the measure of one of those angles. Okay. So does everybody have 1 through 6? Yes? We're good with 1 through 6? Okay. All right, so the next part. On 7 through 15, it says fill in the blank for exercises 7 through 15. The measure of the given angle is blank of the intercepted arcs. So it's either half the measure, half the sum of the measures, or half the difference of the measures. So we just did that with our pictures. If it's a right on the, if the vertex is right on there, like what we had in 3 and 4, it's half of the measure. If it's like outside the circle, it's half the difference. If they cross inside the circle, it's half the sum. So that's what we're going to be doing. You're going to be guessing A, B, or C when we look at these pictures. Okay, so I need to hear from you all. So if you know answers, I need you to unmute yourself so you can answer it. Okay, so on number 7, I didn't draw the picture because I was not trying to draw that complicated picture up here. Okay, it's got too many lines, too many numbers. So you all got it there in your book in front of you. So for angle 1, is that inside the circle or outside the circle?
Outside.
Outside. So since it's outside, it's going to be half the difference of the intercepted arc. So it's going to be choice C, half the difference. Number 8, if you look at angle 2, is it inside or outside the circle?
Outside.
Outside. So is it going to be A, B, or C?
C.
C, half the difference. Okay, if it's outside of the circle where the lines meet, it's the half the difference. If they meet inside the circle, it's half the sum, which was choice B. If they meet on the circle, it's half the actual arc measure. So let's look at number 9, angle 3. Angle 3, if you find it, where it's actually on the circle, correct? Mm-hmm. Everybody see it up there at the top? The vertex of 3 is actually on the circle. So is it going to be A, B, or C?
B.
A. A.
Oh.
Just with the, if the vertex is on the circle, it's A, half the measure of the arc. If it's inside, it's B. If it's outside, it's C. So what about number 10, angle 4? So you find angle 4. Is its vertex on the circle? Where angle 4 is made, its sides meet on the circle, yes or no?
Yes.
Yes, so then it's also going to be
A.
A. Number 11, angle 5, inside, outside?
Outside.
Outside. So outside is
C.
C. Number 12, inside, outside, or on?
On. No, inside.
Inside.
Angle 6 is inside, so that's choice
B.
B, half the sum of the arcs.
Okay.
Number 13, angle 7,
It's on.
on the circle. So if it's on the circle, is that choice A, B, or C?
A.
A.
A. Number 14, angle 8, inside, outside, or on?
Inside.
Inside, so that's choice
B.
B. You will take half of the sum. And then number 15, angle 9, inside or outside or on the circle?
Inside.
Inside, so it will be
B.
the sum. Okay. So what we've been doing in these first 15 problems is making sure you knew those theorems. So you knew whether you were just taking half of the arc, you were taking half the sum of the arcs, if it was inside where they intersect, or half of the difference of the arcs if it was on the outside where they intersect. Okay, that's what that part was all working on, because now it actually wants you to find the angle measures or the arc measures. So you have to you're actually going to have to do the math work now, where you're going to have to know where you take half the angle, half the arc itself, or half the sum, or half the difference. Okay, so that's what we're starting to work on with number 16. Okay, so on number 16, it gives you the variable is at the angle. That angle is inside or outside?
Inside.
Inside. So when we said it's inside, is it half the difference or the sum?
Sum.
Half the sum. So you add the two arcs that it intercepts together. So the two arcs it intercepts are 74 and 82. And then you're going to take half of that. So you just add those two things together, and then we're going to take half of them.
1.
Okay? So 74 plus 82.
The answer is 78.
Okay, he says 78. Y'all agree with him?
Maybe.
Maybe. Maybe you should.
Let me get a calculator.
Wait, what you just did?
On number 16, we're finding the measure. We're finding X in there. See where the X is inside there on the angle? It's an angle that's inside where two secants intersect. So to find the angle inside, it's half the sum of the intercepted arcs. So I took half of the two arc measures added together. So I add these together first, and then I took half of it, divided it by 2, and got 78 degrees. Now, on number 17, you're looking for Y. Y is outside the circle. So when it's outside, do I add them or subtract them?
You subtract.
Subtract them.
So you're gonna have half, and then the two arcs that it intercepts, the big arc shows you as 250 degrees. That's cut off where the two lines cross and touch the circle. And then the little arc on the inside is 64. So you subtract those two numbers and then you divide it by 2. So 250 minus 64.
Is it 218?
Mhm.
The whole thing?
No. Take
I
two,
got 93.
you take 250 minus 64. So 200.
Oh. Oh my God.
What'd you do?
I just added it and then I divided it by 2.
Okay. When the angle is outside of the circle, you subtract them. When the angle is inside, you add them. So we subtract them, you get 186 divided by 2, so it's 93 degrees. Okay. Let's look at number 18. On number 18, you have Z there. Is Z inside the circle, outside the circle, or on the circle?
It's on the circle.
It's on the circle. So if it's on the circle, we do just like what we did yesterday. We don't do any adding or subtracting. We just divide it by 2. We take half of it. So you're going to take half of 214.
107.
So it's 107 degrees for Z. Here, I'll move it over a little bit. That gets that glare off there. Okay. So you're looking at where the lines cross. Okay, if they cross on the circle, you just take half of the arc. If they cross inside the circle, I'm making it worse. Inside the circle, you take half the sum. If they're outside the circle, you take half the difference, you subtract. So on 19, you're looking there at, I think that's an A. It's obviously outside the circle, correct?
Yes.
So if it's outside the circle, I know I gotta do 1/2 times the large arc minus the smaller arc, right?
Yeah.
Now, I've got 2 tangents there. On the picture, the little arc closest to the angle is 112. Did they tell you the big arc?
No.
No, but we can find the big arc because what does the entire circle equal?
360.
360. So this one you got to do a little work over on the side. 360 minus 112 and find the big arc. So 360 minus 112. Everybody agree with that?
Yep.
Okay. And so that's my big arc, and I'm going to take my big arc minus the little arc closest to the angle, and then I'm going to divide it by 2. So I have 248 minus 112, and then divide it by 2.
I got 68.
It's 68 degrees. Okay. So you've got 3 different types of problems, but if you look at the picture, then you can figure out what we got to do. Everybody kind of starting to get a little bit what I'm talking about on these, yes or no?
Yep.
No, yes. Half of you, I see nothing but your room, so I couldn't tell you. Okay. Let's look at number 20. The angle B is there on the outside, correct?
Yeah.
So since it's on the outside, I'm going to do 1/2 big arc minus little arc. I'm going to do 1/2 the big arc that it intercepts minus the little arc that it intercepts because angle B is on the outside. The arc closest to the angle is 124 degrees. Okay? Did they give you the big arc where it intercepts those lines? Yes or no?
No.
No.
And I'm not going to draw this picture well. I know I'm not, but anyway. See, I told you. This goes on the outside. But anyway. So anyway, you've got this little piece down here that it told you is 70, correct?
Yep.
This piece in here was 124. So can I find this other piece that's missing?
Yes.
Because the whole thing equals
360.
360. So you can take 360 minus the 70 plus 24. You got to add the 70 and 24 together first, and then subtract that from 360. 360 minus 94,
166.
266. Right?
Wait, I think I got it wrong.
Okay. So what's 266 minus 124?
142.
So half of 142.
71.
So B is 71. Now we're looking for C. C is in the circle, on the circle, or outside the circle.
In the
On the
circle.
circle.
It's
Yeah,
on the circle. The vertex of C is on the circle. So when it's on the circle, you just take half of the arc that it cuts off of the circle.
Mhm.
So do I know the arc that it cuts off the circle though? Did they label that on the picture? No, they did not. So we have to do what we did up here. We know the entire circle is 360 degrees. So you have 360 minus the two parts that they did give you are what, 130
130 and 40.
and 140. So you add the two parts that it gave you and subtract from 360 to find the part you really need. So 130 and 140 is 270.
Mm-hmm.
90.
360 minus 270,
It's
90.
90. So half of 90, C,
35. No, 45.
45 degrees. So make sure you've got 16 through 21 down, and then I'll roll over to the other side so we can do the ones at the top of page 380 and we'll be done. Still doing the same thing on the next page. You're looking at the picture, figuring out whether it's on the circle, inside the circle, outside the circle, and then finding the measure for the variable. Everybody got through 21 down? We're rolling, we're rolling. Somebody's baby outside is not happy. All right, so here we go. We're ready for 22 through the rest of it right now. Okay, now on these, it's a little bit different. We're still doing the same concept though. It says write and solve an equation to find the value of each variable. Write and solve an equation to find the value of each variable. So on this one, the variable that it's given us is actually the arc, not the angle. On the last section, we were looking for the angle on every one. On this one, we're looking for one of the arc pieces. You still set up the same way, but then we'll have to solve to get the variable by itself. So on this one, is the angle inside or outside?
It's inside.
On 22,
Oh.
the angle where the lines cross is on the outside, the exterior of the circle. Okay, on the outside, the exterior of the circle. So when it's the exterior of the circle, we know the angle, which was 36 degrees, is equal to 1/2 the sum or difference of the two arcs. If it's outside, do we add or subtract?
Subtract.
Subtract. So I would have 86 minus x. That's why these are a little bit different, because the x is on the arc instead of the angle. So we actually have to do a little bit of algebra work. Okay? You set up the equation, the angle is equal to half the difference of the arcs. So now we got to do a little work. We're going to start by doing what property on this side?
Distributive.
Distributive property. So this is going to become 1/2. Well, not, it's not 1/2. Oh, this is why I ended up with ugly fingers. Okay, so half of 86 is
43.
43, and then I would have minus a half x. That's just for me multiplying that part. Okay. Now remember, when you go to solve it, you're trying to get x by itself, correct?
Yes.
So I got to get the 43 over here with the 36. If it's a positive 43, how do I get it with 36?
Subtract 43.
Subtract it from each side. 36 minus 43,
-7.
-7, and that's equal to negative a half x. Now, when we have a fraction in front of our variable, remember, a number right next to a variable is multiplication. The opposite of multiplication is division. But if I'm dividing by a fraction, I multiply by its reciprocal. I flip the fraction over. So 1/2 flipped over is just
2.
See this? Look at my fingers. That's awful. All right, so I multiply by what type of 2?
Negative.
-2 on each side. Because whatever you do on one side of the equation, you do to the other. So a negative times a negative is
A positive.
positive 14. And then over here, the 1/2 and the 2 cancel out, and I'm left with x. So my answer is 14 degrees. So it's using the same concept that we did on 16 through 21 to set up the equations. It's just we actually have to do a little bit of work to solve the equation. I'll just erase the problem numbers so we have a little bit more room to work them out. All right. So, number 23, where the lines cross, is the angle inside or outside the circle?
Inside.
Inside. So since it's inside, the angle measure is going to be equal to half the sum of the two angles. So I'll look at where things are. My angle is the 61 degrees that it has drawn the little line in there. Is that a 1 or a 3? Y'all know I'm blind over here. Try to look on this side so I can see.
1.
61, okay. So I have 61 equals half the sum of the two arcs, which was 85 and y. Yes? And we're solving for y? So are we still going to do distributive property?
Yeah.
Yes. So I have 61 equals half of 85. That's not going to divide evenly. You can have a decimal. Half of 85 is going to be y'all agree with that? Or are you just going to take it, my word for it, because you don't want to divide it? Did I do it right?
Yep.
Okay. And then half of y is 1/2 y. Okay. Now, for here, you're ready to get the y by itself. So I got to move this to the other side first. Since it's positive, to move it to the other side, I subtract it. That cancels. So I have 61 minus 42.5.
18.5.
Okay. And then the opposite of a half we talked about on the previous problem was multiplying by 2 to get it to cancel. So that cancels out and you have y, and then 2 times 18.5.
$37.
So the missing arc measure was 37 degrees. It's doing the same thing we did on 16 through 21. It's just we actually have to do a little bit more work now. Okay? Let's look at number 24. Okay, on 24, is the angle inside or outside?
Inside.
Inside,
Inside.
okay. So we're looking for the ones that intercepts. Now, are the arcs lined up correctly with the angle? Are the arcs lined up right with the angle?
No.
No, they're not. So what we're gonna have to do first is we're gonna take 180 minus the, what is that, 63?
Yes.
So we get the other angle that goes with the arc that we need. So because we know supplementary angles make that straight line. So 180 minus 63 gives you 117. So the angle that actually is lined up with the variable, whatever, z down there, is 117 degrees. Because the way you have it, you have, this one is 63, but I need this one right here, because here is my z, and this is my arc that I have. So I had to find what this angle was. So we did 180 minus that. So what I'm gonna do now is I can set it up. I have my angle was 117, and that's equal to 1/2 the big arc, which was what, 160 something?
164.
Minus the z. And then we're ready to do like we did on the other ones. We're doing distributive property, and then solving to get z by itself. So 117 equals half of 164
82.
minus half z. Then I got to get z by itself. So the opposite of getting the 82, it's positive, so to move to the other side. We subtract 82, yes. Goes poof. What's 117 minus 82?
35.
Y'all agree with him?
Yes.
Now this time I had a negative, so instead of multiplying by a positive 2, I multiply by a, that does not look right. Because the angle was inside, this is supposed to be a plus. And y'all just sit there and let me do it. All right. Right? Okay. So to get rid of the 1/2, I multiply by, what's 2 times 35?
80.
Really?
Yeah.
70, Michael, of course.
70. So z is 70. Okay. Hey, speed up, pick up the pace here. All right. Let's go right here. Number 25. Are we looking inside or outside the circle?
Outside.
The angle's outside the circle, so I subtract. So I have 23 degrees. 1/2 the big arc, which is the B, minus the little arc, which was 56. The same concept, except this time you're looking for the bigger one instead of the smaller one. You use the distributive property to multiply. So I have 23 equals 1/2 B minus half of 56.
28.
28. Now, our goal is still to get the variable by itself. The opposite is subtraction.
Addition.
So we add 28 to both sides. So 23 plus 28.
51. 40.
Huh?
51.
51.
Well,
How do I get rid of half?
Multiply it by its reciprocal, which is 2.
Multiply both sides by 2. So 2 times 51.
102.
102.
102. Okay. On 26 is the angle inside or outside?
Outside.
Outside. Okay. So since it's outside, we need to look at this one. It's similar to what we had to do over there on 24. The angle that I need is not given to me. It gave me one that was outside of there, I believe, or no. No, it's pointing to the right thing. So it's 48, right?
Yeah.
Trying to see where it's at, but it's pointing to the right one. Yeah. So we've got 48 is the angle, and that's equal to 1/2. The big arc was, what is that, 2.6A? Is that what it says?
Mm-hmm.
The big arc was 2.6A
Yeah.
and the little arc was A.
Mhm.
Okay. So 2.6 minus 1 is,
22.5.
no.
1.6.
Minus 1 is 1.6.
Oh.
Oh. And then half of 1.6 is,
0.6.
what's half of 16?
8.
So it's 0.8A. Now, how do I get rid of the 0.8 in front of the A?
Subtract it.
No. When a number's right next to the variable, you get rid of multiplication by
Division.
division. All right. What do you get when you take 48 divided by 0.8?
6. No. 60.
60.
So 60 degrees is your A. Okay? 27. All right, 27. The angle that we have labeled does not go with the arcs that we have. The angle that's labeled is supplementary to the angle that we need. So what we have to do is we first take 180 minus 36. So 180 minus 36 is going to be 144.
Yep.
The angle that we have that we're going to use. So our angle equal to 1/2, and it's inside the picture. So it's 1/2 the sum of the two arcs. So they're going to be added together because that's where the angle is. So you have, what is that at the top? 7C plus 1
Mhm.
plus the arc at the bottom, 11C minus 1.
Minus.
When we go to add that together in there, that better where you can see it. When we go to add this together in there, you got to combine like terms. You got to combine your C's together. And then what happens with plus 1 and minus 1?
They go away.
They go away because they cancel each other out. So 7 plus 11 is
18.
18.
C. So I have half of 18, which is
144.
9.
9. So I have 144 is equal to 9C. To finish getting C by itself, we divide by 9. And so you get what for your C on number 27?
16.
16 degrees. Okay. Number 28 is the one that they gave you inside or outside?
Outside.
Outside, so it's half the difference of the two arcs, correct?
Yes.
So I have the angle, and I'll push this back up. All right, I have the angle, which was, what is that, 36? 36 equals half of d squared minus d. So you have that. Okay. Now, most of you don't want to have a bunch of the fraction in there. If you want, you can get rid of the fraction first. How do we get rid of the half? We multiply by what?
2.
2. So if I go ahead and multiply both sides by 2, that gets rid of that fraction. Multiply by 2 over here, so I have 72 equals d squared minus d. That's going to be easier to work with than having the half in here twice. Now, when you have something like this, the quadratic equation, you got to get everything on one side so it's equal to 0. So to move the 72 over here with it, I subtract 72 from both sides. So d squared minus d minus 72, and it's equal to 0. When you get to this point, we factor. Does anybody remember doing this on some of the other problems we did before spring break? You have subtraction. You're looking for factors of 72 that subtract to equal 1. So what do we multiply to equal 72?
7.
2.
8 and
6. 7.
8 times what is 72?
9.
9. Somebody, all right, get your multiplication tables in there. Okay, now for d squared, I have d and d. One's positive and then one's negative. Now, when you get to this point, you set each factor equal to 0. So I have d plus 8 equals 0 and d minus 9 equals 0. If I have a plus 8 to get rid of it, I do what to both sides?
Subtract it.
Subtract it. So I have d equals negative 8. Now, can I have a negative number for my angle measure? No. Over here, I add 9 to both sides, and I get d equals 9. So that's the one that's going to be your answer.
Okay.
Okay? So everyone needs to make sure they have down through 28. Now, we still have 2 more to do, but we'll wait and do those tomorrow because it's already 10 till. And I'm sure you all are probably like, ready to go, right?
2 dots.
Okay. Now,
Yeah.
tomorrow, when you come, we're going to finish this. Reviewing, you have a worksheet that was in that orange folder. There's a worksheet that was in that orange folder that says arcs and angles on it, which is basically reviewing everything we've been doing this week. Okay? So make sure you have that tomorrow because we're going to finish these problems in the book, 29 and 30, and then we're going to work through that worksheet and review to make sure you know when you add, when you subtract, when you multiply, etc. So you have all that, so you'll be ready to quiz over this stuff next week. Okay? So, everybody good? You know what you got to have for tomorrow?
Yes, ma'am.
All right. So we'll see you all tomorrow at 11. Don't lose this stuff.
Okay, bye.
Bye.
Okay.
Bye.
All right.